Hello everyone, I am Manoj, going to present about the topic of different types of fuses under the guidance of Professor Arjun Jus. If we're going to see about the fuses are designed to open circuits when excessive currents are present due to overloads or faults and to prevent further damage to the system that might result if the fuse were not present. If we see about the different types of the fuses, the common device is in use for overcurrent protection in high current circuits today is circuit breaker. So if we use the different types of fuses, they are revariable fuse, D-type catering fuse, link-type cartridge fuses. Revariable fuses are the fuses that its main composition of a porcelain base which holds the wires. A fuse element is located inside a carrier that is also made of porcelain. It is possible to remove the fuse carrier without any risk of electrical shock. In the D type of cartridge fuse, this cannot be interchanged and comes with the following main components: fuse, base, and cap. Adapter ring and the cartridge. The fuse base has the cap screwed into it, and the cartridge is pushed into it. Circuit becomes complete when the tip of the cartridge is in contact with the conductor. In the link type of cartridge fuse, the knife blade and bolted types are available. There are two types in that. So, in the bolted type, HRC link fuse, the conducting plates are bolted to the base of the fuse. In HRC fuse are a high rupturing capacity fuse. With fuse wire or element can carry short circuit heavy current for a known time period. The next one is GNL/ENE fuse. ENL kind of fuses is mostly used in the cards for the audio system. They are available in various sizes as opposed to others. This one has no wire terminal block. How to check the fuses? In order to check the fuse, a probe is used with readings with terminal. The correct functioning would be when the value is 0 volts DC. Uh, In this category, all fuses of up to 1.5 kilovolts can be included, but most of the typical voltage levels varies from 500 volts, 690 volts, and 750 volts. Next one is high voltage fuses. All fuses used in the power system from 1.5 kV to 138 kV are categorized as high voltage fuses. High voltage fuses are used to protect the instrument transformers used for electricity metering or for power transformers which are expense of a circuit breaker is not unwarranted. They are usually made up of silver, copper, or tin to provide stable and predictable performance. Next one is coordination of fuses in series, where several fuses are connected in series to as the various levels of a power distribution system. It is disable or blow only the fuse electrically closer to the fault. This process is called coordination or discrimination. Next one is resettable fuses. So, as the name indicates, the self-resetting fuses, it can uses a thermoplastic conductive element known as polymeric positive temperature coefficient, that is PPTC. This PPTC thermistor is self-resetting in that when current is removed, the device will cool and revert to low resistance. These devices are often used in aerospace or nuclear applications where replacement is difficult. Next one is thermal fuses. As the name indicates, the thermal fuse activates when the heat of the when the heat increases in the system and the fuses get activated to the heat responding to it. Next one is surface or mount fuses. Yeah, in the surface or mount fuses, they are categorized on the basic levels. And first one is fast acting chip fuses. Our fast acting chip fuses help protect equipment from damage caused by overcurrent conditions when relative quick clear or open time are required in DC power applications. They reduce fuse aging, improve product reliability and resilience. Next one is high current rated fuses. On the high current chip fuses, support for surface mount applications where space is critical and high current is required. In the slow blow chip fuses, it helps in the damage caused by overcurrent events on systems that experience large and frequent current surges as part of their normal operation. Next is telecom fuses. This telecom FT600 fuse offers low temperature, rise performance, and the sneak current fault events to help damage to circuit traces or multiplayer boards. Next one is pulse tolerant chip fuses. This chip fuses help provide over generation protection on systems using DC power sources up to 63 voltage DC. It improves the product reliability and resilience and enhances high temperature performance in wide range of circuit designs. And next one is 0603 very fast acting chip fuses. Very fast acting 200% 300% overloads can act up to the DC 63 voltage DC. The fuse monolithic multi-layer design provides the highest fault current in the smallest footprint, reduces the diffusion related aging, improves product reliability and resilience, and enhances high temperature performance in a wide range of circuit designs. Very fast acting fuses. They are also called as 2410. It wire a SMD fuse which is suitable for the secondary level of current protection application. These lead-free surfaces mount devices offer level 10 have no end funnel. Next one is automotive fuses. If we think about the automotive fuses, they are, the name itself indicates that it can be applicable for the automatic operations. They are some automotive fuses are occasionally used in non-automotive electrical applications. Standards for automatic fuses are publicly SAE International. The fuse devices that are required for the protection from short circuit devices for that are safety in low voltage fuses, safety in high voltage fuses, overcurrents, overloads, short circuits, the concept of controllable fusing. Now, if you come to the conclusion, in the light of the above review study, a clear and brief summary and conclusion is drawn here. The concept of different types of fuses concentrate on safety and protection to minimize the damage from short circuit and overcurrents. A fuse is a small thin conductor designed to melt and separate into two pieces for the purpose of breaking a circuit in the event of excessive current. A circuit breaker is a specially designed switch that automatically opens to interrupt circuit current in the event of an overcurrent condition. They can be tripped thermally by magnetic field or by external device called protective relays. Depending on the design breaker in size and application, fuses are primarily rated in terms of maximum current, but are also rated in terms of how much voltage drop they will safely extend after interrupting a circuit. It was evaluated it was shown that the described new fuse has a high potential for a variety of different applications such as development support, identifying user risk, though the existing fuses are provide possible protection from household and industrial applications, so still more efforts necessary to develop newly designed and more safety and protective fuses which can limit the danger from the short circuit to the maximum extent.